Okay, awesome. So, welcome and thanks for being here. I am Nikki Galloway. I am the Research Data Management Librarian here at ODU. I am joined by my colleague, Maddie Mikovits. She is going to be doing tech support and watching chat and adding links as necessary. So, if you do have any questions, feel free to ask them at any time. As I mentioned, the session is being recorded, and we will share the recording with all registrants, including the slides. But we will stop the recording prior to any Q&A at the end. Okay, so we are offering this workshop as a part of Love Data Week. This is an annual and international celebration of data. It takes place every year during the week of Valentine's Day. This year's theme is Where's the Data? Which aims to get people thinking about the journey that data can take from collection through storage and preservation. Um, if you're interested, you can check out the link to the website, which also lists events being hosted by other institutions. And if you're on campus, please come check out our table in the Learning Commons on the first floor. So our agenda today, this is a little outline of what we're going to talk about. We'll go over a little bit of background and some data definitions to get us all on the same page, some questions to consider when you are searching for data, and some examples and strategies. So even if you don't learn to love finding data, I am hoping that you'll come away with some strategies that will help you at least become more comfortable with the process. So as I mentioned, I am Nikki. This is all of my contact information. You can email me, call me, or make an appointment with me if you have any questions about this or other data management things. Okay, so let's get started with data definitions. First, data is or are different depending on the discipline. They're going to be different depending on who you ask, what subject they generally work in, and any of these and more could be considered data, from numbers in a spreadsheet to audio, video, text, models, even archival material and historical documents. You may collect data yourself. In that case, it would be primary data, or in the case of this workshop, we are going to be looking at strategies for finding secondary data or data that's already been collected, created, or generated by someone else. The data could be quantitative or qualitative. It could be a mixture of both. Other data you might encounter could be observational, experimental, simulation, or compiled. I do want to touch on vocabulary and terminology briefly, because people in different disciplines may call different things by the same or similar name. So my background is in marine geoscience, and coming from an offshore experience, when someone says survey, I automatically think about a boat or a ship that is physically out on the water collecting data with various instruments such as a sonar or a magnetometer. But to a different researcher, a survey could be a questionnaire that is conducted by phone, over the internet, or in person. So just as the sonar is an instrument in the offshore context, the questionnaire is a research tool or instrument, as are observation forms, interview guides. So if you're new to a discipline or searching for data within that discipline, just take some time to familiarize yourself with the terminology that you encounter, and always ask clarifying questions if you have them. So when we're thinking about finding data, before we just dive right in, we want to start by asking ourselves a couple questions. And these could include, what am I looking for? Who creates or collects it? And where do they store it? What you are looking for is going to depend on why you're looking for the data in the first place. So are you trying to answer a research question, make predictions, solve a problem, monitor trends? All of these questions will help you determine where you might look for that data. Data are generated and collected and analyzed by a variety of people, institutions, agencies, companies, communities, for a variety of different purposes. So governments, agencies, and international organizations may collect data about people, the economy, jobs, health, the environment, among probably a lot of other things as well. Researchers will collect and create data that align with their research agenda, their interests, and funding opportunities. Companies can take existing data from a lot of sources and compile them um, in a lot of different ways for users, although these sources can often come at a cost. And then communities may collect their data or data about themselves in the form of oral histories, art, and ephemera. We'll get to some examples coming up, but researchers have a variety of options for where they might store the information, outputs, and data associated with their research project. So this could be in papers that are specifically for code, data, and methods. There are data repositories and archives, and even local storage, which could mean on computer in their office or in a drawer in a lab. So there's a lot of different ways that researchers might store data. Agencies at the city, state, federal, and international level also collect and store data. And a lot of these are called data portals. So I have some examples here of the City of Virginia Beach Open Data Portal, the Norfolk Open Data Portal, and the Virginia Open Data Portal, but a lot of cities and a lot of states will also have these portals. At the federal level, it can be located in each agency, or you can kind of search in bulk for data using data.gov. And also the National Archives and the Smithsonian host a variety of both physical and digital collections. And at the international level, institutions such as UNESCO and the Organization for Economic Cooperation and Development, the OECD, they work to compile and collate data and statistics that will help inform policy and research. You might be looking for something a little less traditional in a sense. This could be in the form of oral histories, art, or the history of a particular community, maybe even yours. And these types of information or communities might not have been created specifically for academic type research, but for individuals to share common interests or a common social, cultural, and historical heritage, and they want to document and preserve that heritage. So these are often grassroots efforts. So if we do plan to use the material for research, I would just recognize that we should be cognizant of the expectations, terms, or conditions that these organizations might have. And I often hear about these through word of mouth or through colleagues or presentations. And I've listed a couple of examples here. So if you're interested, I invite you to explore more. So in addition to asking the main questions of what are we looking for, who creates or collects it, and where do they store it, we can ask a variety of additional questions that'll help us delve a little bit deeper into the what, who, and how. So these might help us refine our search or open up new avenues of discovery that we maybe hadn't thought of before. So we could think about the materials or instruments used in a project, some related fields of study, advocates or opponents of a topic, and the intersection with people, community, and society. Okay, so I'm going to run through a couple examples. The first one is going to be about research papers and publications. So let's say you found a published research paper on your topic, which is great. The author maybe referenced data that they used in the study. So this is a really great start. And historically, a researcher may have only released a final peer-reviewed paper in a journal. But we know that researchers produce a variety of outputs during the research process, including data, code, methods, visualizations, websites, exhibitions, the list goes on. And recently, there has been a movement toward making research and the research process more open. So this would include increased transparency and sharing practices throughout the research lifecycle, which could include open protocols, pre-registrations, methods of preprints, open data collection using or creating open source software, publishing open access, in addition to sharing data and code. I like to caution this though, information and research output should be made as open as possible, but as closed as necessary. So advocates of open data don't necessarily think that everything needs to be made openly available. We need to recognize that there are reasons that some data would not be made public, at least not at a very granular level. So just to take a step back, this diagram shows kind of a broad overview of how the research ecosystem might be connected. So you might have a researcher who's part of an institution, but funded by an external agency. The researcher is going to conduct the research project and release a main output, which is generally a peer-reviewed paper in a journal. But we can see that there might be a variety of related research outputs that might be generated during a project or maybe even after a project concludes. And that might be any books or blogs or podcasts or interviews and even policy documents that may incorporate that research. So if we have the published research paper, we might need to do a little bit investigating to see if the data used has been referenced. So ideally, the article will have a data availability statement, which is becoming a more common practice that's supported by a variety of publishers and journals, which is generally a separate statement in the research article that tells the reader if and what data was used and where it is located. And if it isn't located somewhere that the user can get to it, why not? If there isn't a statement, and this is the case in some disciplines or in older articles, we may need to look somewhere else. The data might be referenced in the acknowledgement sections. It could be in other sections of the paper, including appendices, footnotes in the references, or in supplementary information that might be included with that paper. So I'm going to show an example from PLOS. They require authors to have a data availability statement. And in addition to that statement, if the articles references data that is in a specific repository, PLOS has piloted adding what they're calling kind of a data badge, which will take authors directly to the data set. So that's the example here. Here's the article. And if you scroll down, we can see it has a data availability statement. It has a link here, and then it also has this accessible data. So you can click on this and go directly to that data set. This brings me also to repositories. So researchers can make their data more findable and accessible to others who may want to reuse their data by using a repository, which is an established platform that is also a centralized place to store the data, share data, organize the data, and find data. If you're looking for specific data or information, there might be a domain or a discipline-specific repository. These are a bit more specialized and can be specific to a field of study, a data type, or a data format. But we do know that specific repositories don't exist for all disciplines. And in that case, there are established generalist repositories that support a wide range of disciplines, data types, and formats. Repositories will also often provide the data set with a persistent identifier, which is unique to that data set. It will not change or be reused. So even if the URL changes, that persistent identifier will stay the same and continue to resolve to the data set. And these PIDs, persistent identifiers, make it easier for researchers to link materials together and cite research materials. And persistent identifiers don't just exist for research outputs, they exist for people, organizations, and funders. You may be familiar with the DOI on journal articles. That is one type of persistent identifier. So this slide just shows a selection of both domain-specific and generalist repositories that you may encounter. NIH has a list of domain-specific repositories. Let's see, I think I have that one as well. Yes. So it has a list. You can go to the generalist repositories. I'm on the domain-specific repositories right now. So you can see that they might be specific to a subject area or a center. You can see the access type, but these are very specific to a discipline or a type of data. So you have an open data commons specifically for spinal cord injuries. So you can get very, very specific. The Other types of specific discipline repositories you might encounter for political and social research, you might look into ICPSR. For qualitative data, you may look at the qualitative data repository. If you're interested or curious about repositories in a global sense, you can search and browse the registry of research data repositories. Some generalist repositories, which are more interdisciplinary, include Harvard Dataverse, Bigshare, Zenodo, and these and several other repositories are part of an NIH-supported generalist repository ecosystem initiative. And that aims to develop collaborative approaches for data management and also enable better search and discovery of data. There we go. Okay, so I do want to just briefly circle back to how things are connected through persistent identifiers. So here I have a screenshot from the Dryad repository. So we can see that the authors with this little green button, that's their ORCID ID. So if I wanted to know more about that researcher in particular or what other things they have worked on or published, I could click on that and I would be taken to their ORCID profile. I can also see funding opportunity or who funded this study. So I can click on those and get more information about that. I can also see related works. So I can see the primary journal, I can see other articles, and I can see the preprint. So using all these persistent identifiers, researchers can then identify the linked research components and then start to understand how and why all those items are connected. However, now we've looked at how we might be able to find some data. I do want to reiterate that this is not always an easy or straightforward process. Related information might be in multiple locations. Even if you do find data, it might not be well referenced, described, or documented. In some cases, you may still need to contact the creator, which can prove to be challenging at times. But if data is not where you expected it to be, try not to panic. This can happen for a variety of reasons, and a couple questions we can ask kind of get us back on track include, why might this have happened? Do I expect the information to become available again in the future or maybe in a different location? If not, what do I do? Could the information be located somewhere else? So one reason that we might not be able to find information we want is because it has been permanently archived and the link may have changed. So an example of this is when a new president takes office in the United States, the official files that make up a presidential administration's website are then preserved in the National Archives. A separate entity called the End of Term Web Archive also archives and saves government websites at the end of presidential administrations. It could be that there is a service disruption. So it could be a shutdown or it could be a maintenance window. This could be either expected or unexpected, but hopefully the issue will be resolved. So if the outage is planned, hopefully there will be a notification. Actually, as I was preparing for this workshop, I came across the Densho repository and it was like, oh, it's going to be unavailable due to a maintenance project. It gives us the time and the dates that it's going to be unavailable. So hopefully I started my research project early enough that this window is narrow enough that it's not going to severely impact me. But if I cannot wait, or if I do not know when the website or information will become available again, we can try searching for similar information. It might not be the exact information, but we can try searching for similar information in a different location. So for example, I need US Census data, but the website is down. I could look in Social Explorer, which is a database that the library subscribes to, or I might be able to search in DataLumos, which is a crowdsourced repository that's available freely through ICPSR. If you believe that the data set or information you're looking for has truly been removed or it's been sunset, meaning that the data will no longer be collected for future iterations, you can talk to other researchers, you can try and find a backup or a copy, you can try looking in the Internet Archive and Wayback Machine. And an example of this is the CIA's decision to sunset the World Factbook. So again, that means they're no longer going to provide future iterations of this. The Factbook, if you're not familiar with it, was a one-stop basic reference about countries and communities around the globe, and it was publicly available. So I first saw this announced in a CNN article, and I was like, well, I want to verify that. So I was able to verify it on the CIA webpage. The CNN article actually stated that the data had been downloaded by a programmer who works in data journalism, and the CNN article linked to his weblog, and then that weblog linked to the World Factbook Archive. So there won't be any new iterations of the Factbook. At least the older versions are still accessible. And that's just an example of that here. So you can still access all the previous versions. Okay, so this example just shows that it can take time to search to look for data, but don't get discouraged if you can't find it right away. Hopefully there will be some version of it out there. So there are a couple other ways to search that I just want to touch on briefly. If you're looking to get kind of a broad overview of what data might be available for a given topic, you can try using Google's dataset search or the search functionality in DataCite Commons. So you can search for people, organizations, and works. And in the work search, you can filter down to dataset. So here's an example here of DataCite Commons. I've clicked on the Works tab. I just typed in climate change. And then down here, I can select work type as data set. And then I can just kind of get an overview of what has been published either recently or for specific topics. You can also look for data catalogs. So they might exist for an institution or agency. Catalogs are going to show you information about the data set and how to access it, but the actual data set will be hosted somewhere else. The National Library of Medicine hosts a data catalog that searches multiple data repositories for biomedical data sets. So the user doesn't necessarily have to go to each of those repositories individually to search for related information. They can go to this one catalog and search more broadly. And then associations you are affiliated with may also host data sets, and those might not be hosted elsewhere. The one that comes to my mind is the American Library Association, and they collect data about book bans. The ODU Library also subscribes to over 400 databases. These are searchable index resources that provide access to academic journals, newspapers, and magazines. Some databases will also include ebooks, multimedia art, oral histories, data, and statistics. So I've just listed a couple of those here: Oxford Art Online, History Makers Digital Archive, Wharton Research Data Services, Statistical Abstract. Those are just a couple of them. So if you do want to explore these resources, you can always look at our subject guides or reach out to your subject specialist if you have specific questions. So before we close out, I do want to just conclude with some considerations. So you have found a data set, and that's great. But we want to do some checking to make sure it is the right data for your project. So we may want to take a look at the author and why they might be an authoritative voice on this topic. Has the data been reviewed in any way? Some repositories will offer data curation in which someone will take a look at the data in addition to the data creator, give suggestions, and enrich it. And then we can also look at where the information is published and who is responsible for that and what the purpose of that publisher or repository might be. And then we also want to take a look at relevance. So is the source relevant for your project, and is it going to support your thesis statement or research topic? We also want to think about things like access. So are there any costs associated with accessing the data? Is the data restricted in some way that you would need a memorandum between institutions to access the data, or is it licensed? That also will go into your intent. So can you actually do what you want to do with that data set? Do you want to combine data sets and then release that? Are there any copyright limitations that you may need to work with in order to do that. I'm going to come back to quality and documentation. But attribution, you can always look at related publications. Is proper attribution and citation provided to the data sets? So the first place I was just looking in order to evaluate that data set is the documentation. So does it even exist? Is it thorough? So I just want to bring up a couple examples. So the first example I'll show this time is LDBase. This is an open science resource for the educational and developmental scientific communities. Let's see. So that's what the main page looks like here. And I can go into browse data. I can look at data sets. And then if I look at survey data, I can start looking and seeing, when was the data uploaded? What is the file format? Who are the contributors and the organizations? We can look at the variable type. So we can really start getting a sense of if this data is going to be well suited for your institution or your project. The second one I will show is Zenodo, which is one of the generalist repositories. It's a CERN data center backed repository. So researchers can preserve and share their research from any science, regardless of size or format. And that's what this looks like. I can look at recent uploads. I can search. I can look in communities. So if I browse here and I look in maybe natural sciences, I want to look at data sets again. And then if I can look in here, I start to see, again, we have authors, we have version. So versioning control is very important. We can see the communities it's in, we can see the files, the funding. So we can start to see information about the resource and if it is going to be well suited or not. Okay, so, oh, I missed one. There we go. Keep in mind, so this is going to be a process and it's often iterative. It's going to take time, so start early. But I would just recommend to be intentional, but be adaptable and flexible when you're looking for data. And also just ask questions. The one thing about data discovery is that you don't have to do it alone. So I want to just jump to our library guide on data and statistics real fast because I do have a link to campus resources here. So we have the Division of Research Economic Development. We have campus centers that may be able to assist you. We have the Social Science Research Center, the Center for Geospatial Science Education Analytics. There's a lot of support for undergraduate research on campus. So you don't have to do this alone. You could always ask questions and reach out to people who might be able to help. So with that, I am going to stop the recording and I will open it up for any additional questions.